Today, while you look at delicious cakes and pastries, you'll be learning about 3-3, how to prove lines are parallel. The majority of what we're going to be writing will be going on this top part, no proofs today, and please reserve 6 lines at the very bottom for the very last slide. So in order to prove that lines are blank, we use the converses of the theorems we learned about in 3-2. What are we going to prove? Parallel, of course. Parallel. To prove that lines are parallel, we need to use the converses of the theorems we learned about in 3-2. Now you don't have to copy this, but I hope you recognize it. Let's look at it closer. Do you remember this? Yeah, we did this last class. These were proofs and postulates that we learned about. If a property of parallel lines, that it would have corresponding angles that are congruent, alternate interior angles that are congruent, and same side interior angles. What we're going to do is we're going to write the converse of this conditional, and this conditional, and we're going to use those three, we'll move these back, to create the theorems that can prove that two lines are parallel. Okay, so I want you to notice that we have our previous page here, and we're going to be referencing that. Again, you don't have to copy it. And I want you to notice that there's a delicious cake here. That looks yummy. These are cupcakes. Aren't those cute? I know. Check these out. Cake pops. Yum. All right, now that we're done with that, let's get back to the math. All right, now I said that you can't prove lines parallel unless we turn these theorems and postulates, these right here, we're going to write their converses, and we're going to use those. Here's how they start. If two lines are cut by a transversal, and we're going to add some extra conditions here, then those two lines are parallel. Let's try the first one. Notice that they said that corresponding angles are congruent. So here's how our first postulate will go. If two lines are cut by a transversal and the corresponding angles are congruent, well, then you can say that the lines are congruent. So this is how it reads. If two lines are cut by a transversal and the corresponding angles are congruent, then those two lines are parallel. It's quite a mouthful, but it's exactly what the converse of postulate 10 is. Here's our second one. Our second one talks about alternate interior angles. All right. If two lines are cut by a transversal and the alternate interior angles are congruent, well, then those lines must be parallel then too. There it is. Let me move my cakes over a little. All right, the last one talks about same side interior angles being supplementary, not congruent. So our last theorem will say if two lines are cut by a transversal and the same side interior angles are supplementary, if they're supplementary, then those two lines are parallel. So those are 3 ways that you can prove that two lines are parallel. Just like yesterday, this is the very last slide, so I'd like you to put this in the last six lines. I just want to show this to you. It looks like Pac-Man, doesn't it? Those are cupcakes. Isn't that adorable? I'm going to do that for my birthday. That is cute. Okay, now the last 6 lines of our last notes had to do with perpendicular lines, and so does this. Theorem 3-7 says in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. Let me make that a little bit wider for you. There we go. So let's draw a picture of that. In a plane, you have two lines that are both perpendicular to the same line, that line. Well, then these lines must be parallel. That's what Theorem 3-7 says. That's it. Have a great day.